Okay, sure. So problem 6. This is the second test. Okay. Daniela, last. Okay, so I'm gonna do both the two equations. So first equation. So we have this 2 power x minus 1 equals to this 2 or 3, sorry, minus 2x plus 1. Right? So guys, so this is an exponential equation because, oh, Mamadou, yeah, well, I'm not taking attendance today, so it's the last day of classes, so I'm gonna just take it easy today. So yeah, so this is, I was saying this is exponential equation because there is an x in the exponent. Okay, so whenever you have x, x is in the exponent. You know, when you say exponential, in the word exponential, there's the word exponent, right? So if you have an x in the exponent and you have a constant in the base, okay, so that's what I call an exponential function. That's when you have an x in the exponent. Okay, so this is an exponential. So it's an exponential function because we have x in the exponent. And so because it's exponential functions, so you know, we have an exponential equation. Anyway, in general, I would say the general rule of thumb, I mean, if you want to solve any exponential function, the convention or the most natural thing would be just to apply natural log to both sides. So the idea in general is just to apply natural log to both sides. So this is ln. This is what I call natural log. So this is what I call, this is natural log, ln. So you apply natural log to, yeah, rectine. Yeah, as I said, it's very general. Yeah, I mean, yeah, in this case we have different bases, but if you have the same base, then actually the exponent, they're gonna be equal if you have the same base. Yeah, you're absolutely right. But I mean, as I said, in very general, you would have like different bases. So that's just then you have to apply natural log. So you apply natural log to both sides. So um, so here's my natural log on the left. Here's my natural log on the left equal to this natural log on the right. So on the left side, we do have, it's 2 to the power x minus 1. And on the right side, it's 3 to the minus 2x plus 1. So why do we bother applying this natural log to both sides? Because when you apply a log, one of the main property of the log is that you can bring down the power. So this power here, this exponent here, because you apply the log, you can put the power in front of the log. Okay, same here. I can put this this power in front of the log. So then we're gonna have x minus 1 times. So if you put down this x minus 1 in front of the log, then of course you are left with 2. There's an 2 here inside the log, right? So it's times, so what's left here, it's this natural log of 2. So it's times natural log of 2. Now, guys, this natural log of 2, you can think of this natural log of 2 as it's just a number. It's just a decimal, right? If you use a calculator, then natural log of 2 would be probably 0.67 wherever. So this is just a decimal. So instead of using decimal, I'm gonna just keep the natural log of 2. Okay. So again, just keep in mind this natural log of 2. It's just a number. It's some decimal, and instead of using decimals, I'm gonna just keep the natural log of 2. Okay. Now the right side, the same thing. So you bring down this minus 2x plus 1 times, and of course, then you are left with this natural log. Still have this natural log and 3 inside the natural log. So There's a 3 inside the natural log, so it's natural log of phi. And natural log of phi, again, if you use a calculator, it's going to be probably 1 point something. So it's just a number, right? It's just some decimal, right? And so instead of replacing the natural log of phi with a decimal, I'm going to just keep the natural log of phi. Now we have to solve this equation, right? We have an x on the left, there's an x on the right. So what we do in this case? Well, the idea is to move all the x's on one side and everything else to the right, to the other side, because when you move the x's on the same side, then you can x would be a common factor, so you can factor out x. So you can solve for x. So first, before moving all the x's on the same side, I'm gonna just distribute. So I'm gonna multiply. I'm gonna multiply this x by this number, natural log of 2. It's again, it's just some decimal, and then the 1 here by this number. The same here, this minus 2x plus minus 2x times natural log of phi and plus 1 times natural log of phi. So we're gonna have x times natural log of 2, and then there's this minus. So here's my minus. It's 1 times natural log of 2. That's the left side. The right side, we're gonna have minus 2x times natural log of phi, and then there's a plus. So I'm gonna keep the plus, of course. There's 1 times natural log of phi. Now, as I said, there's an x in here, left side. There's an x on the right side. So I'm gonna just move the x on the same side. So I can factor out the x. So I'm gonna add plus 2x. This is a minus. So I'm gonna have plus 2x times this number here, natural log of phi. And of course, I have to do the same thing on the other side. So it's plus 2x times this natural log of phi. Now, so this thing here is going to cancel out. It's minus a plus, so cancel out, same thing. So then it's just x times natural log of 2 plus this 2x times natural log of phi. And then there's this minus 1 times natural log of 2. Well, 1 times any number, a decimal or fraction or wherever, 1 times any number is going to be just the same number. So it's natural log of 2. And the right side, it's 1 times natural log of phi, same thing. It's going to be just the same number, which is natural log of 3. Now, I have an x in here. That's good. An x in here, right? So we can factor out the x. But then there's a third term here, this one here. There's no x in there, right? So I have to move to the other side because there's no x in there. So it's a minus, so I'm gonna need a plus natural log of 2. So it's a plus natural log of 2. All right, so then this natural log of 2, of course, cancel out. So now I have on the left, I'm gonna have x. I'm gonna have x times natural log of 2 plus 2x times natural log of phi. That's the left side. The right side, it's just natural log of phi plus natural log of 2. Right. Now, I can pull out my x. This is an x in here. There's an x in here. So I'm going to factor out the x. So here's my x times. You pull out the x here. Then you are left with natural log of 2. You pull out the x in here. You are left with this 2 times natural log of phi. So it's 2 times natural log of phi equals to this natural log of phi plus natural log of 2. So you see, guys, the point why we move all the x's to the same side and everything else on the right side, because now I can divide and I can get my x. So I'm going to divide by this number here, wherever number it is. It's just I'm going to just divide by the same thing. So it's natural log of 2 plus 2 times natural log of phi. Right, so because when you divide by the same thing, then it's gonna be just it's gonna cancel out. It's gonna be just equal to 1, right? This thing here. But then, of course, you have to divide by the same thing on the right side. So here I have to divide by the same thing. So it's natural log of 2 plus this 2 natural log of phi. Oh, no problem, Elisa, if you miss the plus. I mean, you will probably get full credit. I mean, if it's a minor, very minor mistake, then it's not a problem. So then a minus. All right. Yeah, I see. So yeah, so then your x is just a natural log of 3 plus this natural log of 2. And then in the bottom, it's natural log of 2 plus 2 natural log of 3. And that would be the answer. All right. So of course you can use a calculator if you wanna figure out what's this number, natural log of 3 plus natural log of 2 over natural log of 2, etc. You can use a calculator to try to find this number, but it's not. I mean, it's not worth it, right? It's not. You can just so this would be a fine answer. Right. Where did the minus go? Well, it was a minus here. Here's a minus, right? So I added plus here, plus 2x. There's a plus 2x here, right? Because minus plus, they would cancel out, right? So minus plus the same thing, they would cancel out. So it's, I added plus 2x natural log of 3, right? So here, it's a minus, so I added plus 2x, so then times natural log of 3, so then the whole thing cancel out, right? It's minus plus the same thing. Does this answer your question, Samira? Yeah, so that's where the minus went. So it's just because I added plus 2x times natural log of 3, so then the minus just disappeared. All right, any other question, guys? You got minus same answer. Well, I don't know. I didn't grade the I didn't grade the test yet, so I don't know exactly what was your answer. Cheyenne, you're saying I did a little different. Well, of course, but I mean, like you know, in this step here, instead of adding this 2x natural log of 3, you can, for example, subtract this x here, x natural log of 2. You can subtract, decide to subtract this x natural log of 2, so then you can move the x's on the right side instead of the left side. But yeah, but of course you should get the same answer, right? It doesn't matter how you solve this equation, but you should get this answer. If you don't get exactly this answer, then I think you did the mistake somewhere. But it's fine. I mean, if minus or plus, it doesn't matter for me when I grade. I mean, plus or minus a minor mistake. If your steps are correct and you're following the right, you did the right steps and everything. There's a minor mistake, then you would get full credit for sure. All right. Any other question about this number, this problem? Oh yeah, so I'm gonna do the next one. Yeah, sure. So for number 2, okay, so it's e to the 5x minus 2 equals to 1. So this e, guys, it's just approximately, it's 2.71 something. So it's just a decimal, it's just some number, right? This e is just some number, and you will see in Calc 1, this number is kind of very special. And you will see why in Calc 1, right? It's because it's above the derivative, but you see that in Calc 1. But anyway, so you have this e, which is a number, so it's a constant. So this is a constant, right? It's a constant, and you have an x in the exponent. X is in the exponent, so that's an exponential function, right? You have a constant, and then exponent, you have an x, so that's an exponential. exponential function. So we do have an exponential equation here. As I said, general rule of thumb is just to apply natural log both sides. So I'm gonna just apply natural log both sides. I'm applying natural log because, you know, it's called natural log because that's like a kind of like the convention is just to apply a natural log. Of course, you can apply a different log, I mean, log in different base, right? This natural log, this is a log in base E, right? But of course, you can apply a log in different base and you would have like a different, not different answer, but like the answer expressed in a different base. But it doesn't matter. But again, this is, we apply natural log. This is because this is like sort of a convention. That's what people use to solve this most of the time, to solve these kind of equations. Just apply natural log. So in this case, left side, of course, it's e 5x minus 2, and here it's 1. Now, again, we are applying log, so then this power is going to be in front of the log. So we're going to have this 5x minus 2 times this natural log of e times natural log of 1. Now, guys, you have to remember so some properties of log. Log of 1 in any base, log of 1 in any base, it doesn't matter the base, a could be any number. So log of 1 in any base is always 0, okay? And so this log of 1, natural log of 1, so this natural log of 1 is going to be 0, okay? So keep in mind, log of 1, it doesn't matter the base, it's just 0. Now, the other property of the log is that if you have a log of a in base a in base a, then this is always equal to 1. Okay. Now, you have this, you see this natural log of e? Well, so what's the definition of natural log? Well, natural log of e, well, I mean, natural log by definition, that's a log in base e. So this is log in base e of e. And log, as I said, log of a in base a is 1. So this natural log of e is equal to 1. So this number here, this is just equal to 1. Okay. So then, so now the equation is very, very simple. It's just, so now we have 5x minus 2 times 1 equal to 0. So it's just 5x minus 2 equal to 0. So plus 2 both sides, and then, so it's 5x equal to 2. And then, of course, we divide by 5. So then your x is 2 over 5. And this should be your final answer. If you don't replace this natural log of e by 1 and natural log of 1 by 0, I think I won't give you the full credit, because you need to know, this is like you need to know by heart, the log of 1 doesn't matter the base, log of 1 is 0, and log in base a of a, it's always 1, right? Yelisa, you did, yeah, I mean, if you get the same answer and you did different way, that's fine. I mean, I'm not saying this is like the unique way, right? So all I'm saying, this should be your answer. And of course, you could do it like a different way. Is there any question, guys? So yeah, so we have this, if you have a log or exponential equations and you have log of 1, so you have to remember, guys, log of 1 is always 0. So what did you do, Elisa? Let me see. I did e to the power and then solve. Oh, okay, yeah. So because you're saying 1 would be e to the power 0, and then it would have the same base. So yeah, it's actually the same. Yeah. Okay, I see what you did. Yeah, that's another way to do it. But actually, they are, I mean, just equivalent. And of course, you would get the same answer. Any other question, guys? All right, so no questions about this problem number 6. All right, So before the trig problem, so I'm gonna try again, go over this the second test. So first problem, as I said, polynomial, graphing polynomial, then inequality. I don't know if Cheyenne, you're saying, can we go over number one? Yes, sure. I can do that, sure. All right, so for number one, okay, so this is problem number one. Test, right? Okay, so f of x, it's this, where is it? So it's x cubed minus 5 plus 7 x minus 3. Or, sorry, 5x minus 5x squared, sorry, plus 7x minus 3. So first, the rationals, the possible rational roots. So the possible rational roots. So just remind you guys, so what you do in this case, you have to take the factors of the constant, factors of a0 over factors of the leading coefficient, so factors of an, right? So what I'm saying here is you have to take the factors of the a0. The a0, that's the constant, that's the last coefficients. This is the constant. All right, so it's a 3 or negative 3. And then the an, that's the a subscript n, that's the leading coefficient. So here it's 1 x cubed. So this one here, that's my an. So that's my leading coefficient. All right, so here basic, so we have to take the factors of negative 3. It doesn't matter negative 3 or positive 3. I mean, as I said, from the list of possible rational solutions or roots, anyway, you have to take plus or minus. So it doesn't matter if negative 3 or positive 3. Here, factors and over factors of 1. So factors of 3, 3 divisible by 1, and 3 divisible by itself, right? And factors of 1, well, 1 is only divisible by 1, of course. So then the list, so the answer, list of possible rational roots. So you have to take the first factor here, and you divide it by the 1, so it's 1 over 1, so it's plus or minus 1. And then take the second factor here in this list, and then you divide it by 1, so it's plus or minus 3 over 1, so it's 3. All right, so that's the answer. It's plus minus 1 or plus minus 3. Please interrupt me, guys. I mean, if you have any questions, please let me know, right? Yes?
I got that part right, but then the factoring part, the part 2, that's where I was like having trouble.
Okay, yeah, okay. So yeah, I'm gonna do the that's for this yeah, I'm gonna solve the whole problem anyway. So yeah, sure. So this for number 2, I'm gonna factors f of x completely. So how do we factor f of x completely? First step, you have to try the numbers in the list, to find, so you try the numbers to find one solution, one solution of f of x equal to 0. Okay. So I'm gonna try the numbers in the list to see if I get yes, Yelisa, absolutely. So positive 1 would be a solution. So first number in the list. So this, as I said, in the test on the final, probably the first or second number would be a solution. So if you try positive 1, that's the first number in the list, right? So I'm gonna plug positive 1 in my function f. So let's say try positive 1. Okay, so f of positive 1 would be, of course, so it's 1 cubed minus 5 times 1 squared plus 7 times 1 minus 3. So that's 1 minus 5 plus 7 minus 3. 1 minus 5 is negative 4 plus 7, that's positive 3. Minus 3 is 0. So we get 0. So you see here, guys, if you get 0, okay, then you can stop. And then, so x equal to 1 is the solution. So x equal to positive 1 is a solution. So once you get the solution, then the next step would be to divide f of x by the x minus that solution. So is a solution. Okay, so you get one solution. So then you can move to the next step, step number 2. So in this step number 2, so we can move to the second step once you get the solution. So then you can divide f of x by x minus the solution. Okay, so why do we divide f of x by x minus the solution? Because because 1 is this plus 1 is a solution, then x minus solution is going to be a factor of f of x. It's like saying f of x is going to be divisible by x minus the solution, right? So what we are saying is here is that, so why do we divide f of x by x minus the solution? Because f of x is always divisible by x minus the solution. It's like saying 8 is divisible by 2. So then I can write 8 as 2 times 4, right? So then I get a factorization of 8. 8 would be 2 times 4 because 8 is divisible by 2, right? The same thing here. So if you have a solution, it means that your f of x is going to be divisible by x minus that solution. So then you can factor f of x. So x minus the solution is going to be a factor of f of x. So in other words, so x minus the solution is a factor of f of x. All right, so let's divide. So I'm going to divide. So I'm going to divide f of x, which is x cubed minus 5x squared plus 7x minus 3 by x minus the solution, and the solution is positive 1, so x minus 1. All right, so this is just division of polynomials, so we know how to do that. So it's just so here's my first row. So we're gonna have first column, first row. We're gonna put the c. So this is x minus c. Remember, c should be the opposite. Here it's x minus 1. So my c is gonna be positive 1. All right. So my c is positive 1. And then I'm going to put my f of x. Here's my f of x. So it's x cubed. So it's 1 x cubed, 5 minus 5x squared, plus 7x, and plus 3, constant. This is the constant. Right? And then, so what we do is, of course, so we bring down this first number here. So it's going to be 1. And then you multiply. So 1 times 1 is going to be positive 1. So here's my positive 1. Negative 5 plus 1, it's negative 4. Negative 4 times 1, it's negative 4. 7. So here's addition, of course. Here's a plus. So 7 times plus negative 4. So that's positive 3. Sorry. So this is a negative 3, of course. Right? This is a minus 3, so it's negative 3. So 7 plus negative 4 is positive 3. 3 times 1, it's positive 3. And negative 3 plus 3, that's 0. So if you don't get 0 in the last column, last row, then it means that you made a mistake somewhere, guys. So this is your remainder, and it must be 0 because 1 is supposed to be a solution. So the remainder must be 0. Right? And of course, this would be our quotient. Okay, so it's 1 degree less. So if you have x cubed here, then it's 1 degree less. So it's x squared. This is x squared. So here it's 1 degree less. So it's x here. So then here's the constant. So in other words, what we are saying, guys, is that so f of x, it's equal to the divisor divided by x minus 1. So divisor times the quotient plus, of course, the remainder, right? So now, so f of x, we divided by x minus 1, and we got the quotient, which is 1x squared minus 4x plus 3, right? And then the remainder is 0, right? So this is just 0, right? The remainder is 0. So here you see we got this, so we have this factorization of f of x. So it's x minus 1 times, so f of x, it's actually x minus 1 times x squared minus 4x plus 3. All right. Well, we have to factor f of x completely, right? So this is our first factor, first factor. Now we have to factor the x squared x squared minus 4x plus 3, right? So how do we factor x squared minus 4x plus 3? Well, of course, there are different ways to factor this, x squared minus 4x plus 3. So then, well, one way would be just to solve. You can just solve this x squared minus 4x plus 3. So we, as I said, so we have to factor now. Again, we want a complete factorization of f of x, right? X minus 1 is my first factor. Now I need to factorize this x squared minus 4x plus 3. So we have to factorize this x squared minus 4x plus 3. And one way to do it is just to solve x squared minus 4x plus 3. Right, so then this is just a quadratic equation. So then your x is a minus b plus or minus square root of b squared minus 4 squared, that's 16, minus 4 times a times c over 2. So your x is 4 plus or minus 16 minus 12, that's 4, square root of 4, it's 2, so it's plus minus 4, 2. So x is 4 plus 2 over 2, that's 6 over 2, that's 3, or x is 4 minus 2 over 2, it's 2 over 2 equal to 1. So you got 3 and you got positive 1. Kwame, you have a question? Oh yeah, of course, Kwame. You can use you can use a different method if you want. Yeah, sure, no problem. Yeah, the most important thing is you get the right answer. Sure. So so what I'm saying, guys, is that this because you have 3 and 1, so then this x squared minus 4x plus 3 can be written as x minus 3 times x minus 1. So so what I'm saying is that, so then this x minus 4x plus 3 would be x minus the first solution here, this one here, times x minus the second solution here, this one here. All right, so then your x squared minus 4x plus 3, it's just x minus 3 times x minus 1. All right, this is just one way or one method to yes, yes, absolutely. So x minus 1 is going to have multiplicity 2. So now to answer, final answer to the question. So remind you our f of x. We said our f of x is this thing here, right? It's this x minus 1 times the x squared minus 4x plus 3. But now x squared minus 4x plus 3, it turns out to be, so x minus 1 times x, you see here, it's x minus 3 times x minus 1. All right. So actually your f of x is going to be x minus 1 square, right? Because I have 2x minus 1, right? This x minus 1 here, x minus 1 here. So it's x minus 1 square times the x minus 3. Right? And so that's the final answer. This is a complete factorization of f of x, right? This is the first factor, second factor, the third factor. It's like saying 8 is 2 times 2 times 2, right? That's a factorization of 8. So the same thing here, guys. It's a polynomial, so you have to write it like a product of factors. And the factor, when I say a factor, it's x minus let's say some number, right? Anyway, so that's for the complete factorization of f of x. Is there any question, guys, about this complete factorization? So now, once you get the complete factorization, then you can find the x-intercept and their multiplicities very easy. So, to answer the question number 3, so the 3 now, the x-intercept well, all you have to do is solve f of x equal to 0, right? But then, because f of x is a product, f of x, we said it's x minus 1 times x minus 3 times x minus 1, right? It's a product which is equal to 0. It's a product which is equal to 0. Then one of the factors is 0. So then x minus 1 is 0, or the x minus 3 is 0, or the x minus 1 is 0. Right? So of course, this is x minus 1 is 0, then x is equal to 1, x equal to positive 3. All right, and again, we're going to have the same x minus 1 here. It's 2 times solution of this, right? It's we have x minus 1 square, right? So the x equal to 1, it's 2 times solution of this f of x. Anyway, so to answer the question, the x-intercept, I got 1 and 3, right? So answer. So the x-intercepts are, so 1, so we have 1, 0, and 3, right? So 3, 0. Now, what about the multiplicity? So as I said, 1, it's of multiplicity, as Elisa said, it's a multiplicity 2 because it's x minus 1 square, right? It's a 2 times solution, right? It's x minus 1 square. So because of this square, so this is of multiplicity 2. Okay, multiplicity 2. Now, what about the 3? Well, it's just x minus 3 to power 1. It's just 1 time solution. It's power 1. So this 3 is of multiplicity 1. Okay. Any question, guys? So you see, that's why this factorization is very useful, because once you get the factorization, and you want to solve your function equal to 0, you have factorization. It means you have a product, and when you have a product equal to 0, then one of the terms is 0. If you have a product with some number equal to 0, then you cannot say anything, right? So the thing is, why this factorization? Why do we bother with the factorization? Because again, guys, the idea is if you have here, let's say you have this factorization plus, let's say, I don't know, let's say plus here plus 3 equal to 0, right? So if you have some plus, you have a product, and then you have plus 3 equal to 0, then actually you cannot deduce anything. You cannot really solve this. You cannot really say x is 1 or x is 3 or whatever, right? So because it's just a product, it's only a product equal to 0, then yes, then one of the factors would be 0. Otherwise, if you have a plus, if your remainder is not 0, then you cannot really solve the equation, right? Anyway, I don't know if there's any question. Let's see the chat. Oh yeah, okay, no question. Good. Now find the y-intercept. Well, y-intercept is just it's just let me see here. So the y-intercept would be the y-intercept. It's just you have to evaluate f of 0. F of 0. So f of 0 would be just 0 cube, 5 0 square, plus 7 times 0 minus 3, so it's negative 3. So the answer here, y-intercept, is just negative 3. Right? Now, the behavior at infinity, just be careful, guys, here. So this is for a 5. So your f of x, it's it's x cubed, 5x squared plus 7x minus 3. So the degree of f, the highest power of x is 3. That's odd, right? And the leading coefficient is 1. It's positive. So leading coefficient is positive. Is positive. So in that case, we said, so the behavior at infinity, we're going to have the following. So we're going to have the following thing. So the graph at infinity would be, at positive infinity would be somewhere here, and at negative infinity is going to be somewhere here. All right. Now, now you want to graph the function. Well, so now it's just, so now for 6, the graph. You're going to need the x-intercept. So we have 1 and 3. They are my x-intercept, right? 1 and 3. Y-intercept, it's negative 3. So my y-intercept is somewhere here. It's negative 3. So here's my y-intercept. Now at infinity, we said, so it's going to be at positive infinity, it's going to be somewhere here. And at negative infinity, it's going to be somewhere here. All right. And what else? Well, that's it. Now I'm going to just join the points and make sure I have to check the multiplicities of the x-intercept, right? So I'm going to start from here. Next point would be my this y-intercept. Now I'm going to 1. Now, guys, 1, the x-intercept 1, we said it's of multiplicity 2, right? So multiplicity is even. And when the multiplicity is even, we have to, touch the x-axis and turn around the point. So I'm going to touch the x-axis at 1 and then turn around. Okay, that's because the multiplicity is even. Now, next point would be 3, of course. And then at 3 is the multiplicity of 3 is 1, which is odd. So all you have to do is just cross the x-axis. I'm going to cross the x-axis, and then I'm going to go to my positive infinity. All right, so that would be the graph of f of x.
So we only cross the x when the however
Yeah,
you say
multiplicity is odd. Yes,
it,
when the multiplicity is odd, you cross the x-axis. When the multiplicity is even, you have to turn around the x-axis. All right. Well, I think you had the trouble with the signs,
I had
Elisa.
trouble with the drawing, but I got everything the same.
Yeah, I mean, the drawing. You see,
I just
once you do.
counted from 1 to 3 and
Uh-huh.
on the top over the y intercept and then go
The
back.
intercept. Oh, I see. Yeah. Yeah, I understand. But I mean, you know, you plot you plot your y-intercept, your x-intercept, and then you have to connect them, right? Of course, you need the right behavior at infinity, right? So you know that you start like from here, right? You start from here, and you know that you have to go to the next point would be this y-intercept. You go to the next point, which is an x-intercept. Make sure about the multiplicity. This is even, so you turn around. You go to the next point, x-intercept. This is odd. You cross your x-axis and you go to your infinity, and that's it.
Forget about that.
Yeah.
Get some credit because I did
No,
everything.
well, I mean, as
Last
Elisa said, yeah, as Elisa said, you know, so sometimes you're under pressure. When you're under pressure, you know, in the test, it's just. I mean, even something which is obvious, sometimes it just becomes very kind of hard. But anyway, it's yeah. So what I'm gonna say, yeah. So is there any question about this first problem, the second test? I mean, you should expect similar problems in the similar problem in the final, right? So it's I mean, graphing polynomials is very important. You need to know how to graph polynomials. Kwame, you're saying it's long. Well, it's long if you don't practice. Of course, that would that would be long. It would take a lot of time. But if you you know if you did your the problems in the homework, so it's just similar problems, right? It's kind of it's just the same stuff, right? So you're supposed to be more I guess more faster, right? Yeah, but I know, especially the factorization. Factorization is sometimes kind of well, it's long because I guess because I try to explain all the details, but probably factorization is the longest step. Lenin, you were saying problem 4. Sure. So I'm gonna do the problem 4, and then I'm gonna talk about the first test a little bit because as I said, the final it's would cover everything, guys. So you should expect problems from the first and the second. So I'm gonna do problem 4, then I'm gonna go with the first test. Probably gonna go over one problem or two problems first test, and then I'm gonna do a one trig problem. Okay. So, right. So let's do the problem number 4. Okay. So problem 4. So this is second test, test number 2. All right. So it's about rational functions. I guess probably some of you had trouble with graphing rational functions. I know it's not obvious, but anyway, so it's x minus 4, x plus 1. First, the x-intercept. So for the x-intercept, you have to solve f of x equal to 0. And we said when you have a fraction, f of x equal to 0, when you have a fraction equal to 0, that means that the top is 0. Okay, whenever you have a fraction equal to 0, if your top is 0, then the whole fraction is 0. Of course, you don't really care about the bottom because we're not allowed to divide by 0. So f of x is 0, it means the top is 0. It means the x minus 2, x plus c is 0. So then either the x minus 2 is 0, or the x plus t is 0. So this is x is positive 2, and this is x is negative 3. So the answer, it's 2 and negative 3. All right, that's for the x-intercept. The y-intercept, you just evaluate f of 0. You evaluate f of 0, so just plug 0. F of 0, you plug 0 in the function. Just be careful when you multiply. This is multiplication here. 0 plus 3 over 0 minus 4, 0 plus 1. So the top is negative 2 times 3. That's negative 6 over negative 4. So negative over negative is positive. 6 over 4, you reduce the fraction, so that's 3 over 2. All right, so the answer is 3 over 2. The vertical asymptote. Vertical asymptote, we said that's where the bottom is equal to 0. That's our vertical asymptote. So that's where the bottom is 0. And the bottom, it's x minus 4. X plus 1 is 0. So either the x minus 4 is 0. X plus 1 is 0. And so the answer, vertical asymptote, would be x equal to positive 4 and x equal to negative 1. Right, that's my vertical asymptote. And then vertical asymptote, and then of course the horizontal asymptote. So the horizontal asymptote, guys, I mean, we said we're supposed to compare the degrees of the top and the bottom. I mean, this is of course x minus 2 times x plus 3 over x minus 4, x plus 1. So it's you have to expand the top because you want to figure out the degree of the top. So it's x times x, it's x squared plus 3x minus 2x minus 6 over same thing, x squared plus x minus 4x and minus 4. So the degrees, the top, the highest power of x is 2. The bottom, the highest power of x is 2, so they are equal. And so if they are equal, then the horizontal asymptote would be the ratio of the leading coefficient. So the horizontal asymptote, so this is the answer. So the horizontal asymptote would be the ratio of the leading coefficient. So it's going to be 1 over 1, which is equal to 1, right? That's because I have 1x squared here and 1x squared in the bottom. If it was like 2x squared in the top and 3x squared in the bottom, that would be 2/3. Okay, so you take the ratio of the leading coefficient. That's my horizontal asymptote, and then you have to, I guess that's the difficult part here is to graph. So to graph this f of x, the graph. So in the graph, guys, first you have to draw your. Well, you just yeah. Yeah, I guess the graph is like the most difficult part here. So we have to draw the vertical asymptote. So it's x equal to 4. This is 1, 2, 3, 4. So here's my first vertical asymptote, x equal to 4, and the other one it's x equal to negative 1. So here's my negative 1. So this is x equal to negative 1. So this is my vertical asymptote, right? 4 and negative 1. The y-intercept, sorry, the x-intercept. So we said x-intercept is x equal to 2. So here's my x-intercept, x equal to 2. and x equal to -3. So I'm gonna need -3 here. My -3. The y-intercept, we said it's 3/2, right? How do we graph 3/2? You mean how do we plot the 3 over? Well, it's 3/2 is 1.5, right? So it's you know, this is like 1 here, and here's 2. So 3/2, it's 1.5, and so it's just between 1 and 2, right? In the middle here. That's my 1/1/2, 1.5, right? That's my 3/2. Right? This is the 3/2. It's 1.5, right? And what else? I have my, and then I have my, of course, my horizontal asymptote. That's y equals to 1. This is my horizontal asymptote. All right, that's my horizontal asymptote. All right, so anyway, guys, so for the graph, you start from the horizontal asymptote. On the left, you start from the left, of course, from the left to the right. So here on the left, here's my horizontal asymptote. So your graph should be close to the horizontal asymptote. And of course, there are two options. You can have your graph above the horizontal asymptote or below the horizontal asymptote, right? It's close, doesn't intersect the horizontal asymptote. So there are two options. Now the thing, guys, the thing is I have this x-intercept at -3, right? So after I start from my horizontal asymptote, I have to join or connect this x-intercept at -3. And again, the idea is if you are above the horizontal asymptote, and again, you are not supposed to cross the horizontal asymptote at the infinity. So when you're close to infinity, so actually you're not supposed to cross your horizontal asymptote. Okay, you have to go to this -3, right? And you are not allowed to cross this horizontal asymptote at -infinity. So then the right thing to do here is to start below the horizontal asymptote. Right, so oops. So we should start below the horizontal asymptote and go to our x-intercept. All right, and then you go to your x-intercept, but then of course once you go to your x-intercept -3, but then there is this green vertical line. That's our vertical asymptote, and because it's a vertical asymptote, it means that your graph should be close, should be very close to your vertical asymptote, right? So there are two options: either you can go up or you go down. But the thing is, if you go up, you're gonna cross the x-axis and you're gonna have an x-intercept there, but there's no x-intercept there, right? So you have to go down, all the way down, right? So this is here, we are not allowed to cross the x-axis there because there is no x-intercept there. So we have to go all the way down here, right? So now on the right side of -1, we're gonna have again two options. Either you would start from the top here. Right, so let me just here's my vertical asymptote, or of course from the bottom here, right? Again, you have to be close to your vertical asymptote. Now, if you start from the bottom, guys, the next point would be this y-intercept. So if you're gonna go to this y-intercept, then it means you're gonna intersect the x-axis here. But we don't have an x-intercept there, so we're not allowed to cross the x-axis there. So the only way is to start from the top here and go down to this 3/2. Okay, because if you start from the bottom and you go to the 3/2, then you have to cross the x-axis, but then you're gonna have an x-intercept, but you don't have an x-intercept, so you are not allowed to cross the x-axis there. So this is not the right thing to do. That's not correct. Right now, I am at 3/2, right? The next thing is, or next point is the 2. So you see, guys, here I can cross my my horizontal asymptote here because again, if you are like in the middle of the graph, you can cross your horizontal asymptote. That's not a problem. But you cannot cross the horizontal asymptote when you are at infinity here, okay, or here, okay. But in the middle, it's fine. You can just you can cross the horizontal asymptote. All right. So yeah, I'm gonna go to the 2. This is my 2. Oops. I got here my x-intercept at 2. Now next, of course, is gonna have this vertical asymptote at 4, and you're gonna have 2 options. Then, of course, as usual, I mean, if you're gonna go up, you're gonna cross the x-axis. You would have an x-intercept, but you don't have an x-intercept there, so you cannot cross the x-axis. So I cannot go up, so I have to go all the way down here. All right. Now, last thing, of course, I'm gonna have 2 options. You can start either from the top or from down. But then the thing is, here's my horizontal asymptote, and your graph is supposed to be below or above the horizontal asymptote. Now, if you start down here and you go to this your horizontal asymptote, then you're gonna have an x-intercept here, right? But you don't have an x-intercept there. So the right thing to do is to start from the top and go down. So the right thing would be just to start from the top and go down here. And so that's the graph of f of x. Okay. Anyway, is there any question, guys? I mean, that's the general idea. So this is for the second test. I'm gonna discuss a little bit the first test. I don't know if you guys have access to the first test, or if you have your first test in your computer. But so for the first test, guys, I would say the main problems in the first test are first about the domain of functions. So when the first test, like the problem number 2, where you have to find the domain of functions. So remember, for the domain, there are mainly two cases. If you have a fraction, you have to solve the bottom equal to 0. And if you have a square root, you have to solve what's under the square root larger or equal to 0. What else? There is also what's really important is finding the inverse of a function f. Probably I can do an example. Finding an inverse of a function f. What else? Let's see. Oh yeah, there's also the transformations, guys. Remember these transformations, the horizontal shift, vertical shift, etc. Anyway, I don't know if there's a specific question about the first test, or if you have guys access to the first test, that would be great. But otherwise, I can probably do 1 problem or 2 problems from the first test. Let's see. For example, let's see. Let's do a problem finding the inverse function, right? So, so this is from the first test. So problem number 7. This is test number 1. Okay, so just to remind you guys how we find the inverse of a function f, right? So the question is to find the inverse of f of x equals to x plus 3 over 1 plus minus 2x, right? So okay, so first step, we said we have to replace this f of x by y. So y equals to x plus 3 over 1 minus 2x, right? That's the first step. So step 1, let's replace f of x by y. It's f of x by y, right? And then next step is to interchange x and y. Interchange x and y. So x and y. So then y becomes x and x becomes y. So this is y here, and there's y in the bottom. So it's y plus t over 1 plus, or 1, sorry, 1 minus 2y. And then we said the last step would be to solve, step 3 would be to solve for y. Solve for y. So in this case, we have as fraction, so x over 1 equals to this y plus 3 over 1 minus 2y. So what we can do, guys, in this case, we have two equal fractions. So then you can say that, so we can cross multiply. Okay, so when you cross multiply, it means that your x times the 1 plus or 1 minus 2y is equal to 1 times 1 plus y plus 3. All right. So then you distribute x times 1 is x minus x times 2y is 2xy. The right side, we have y plus 3. Right? I want to solve for y, of course. So if you want to solve for y, so we have to move all the y's on the same side. So I'm going to move this y here to the right side. So that's minus 2xy. So I'm going to add plus 2xy, plus 2xy. And then, so then this minus 2xy plus 2xy cancel out. So it's just x now. Y plus 2xy plus 3. Now, I can, y is a common factor here, but here, this 3 here, there's no y in 3, right? So I'm going to move this 3 to the other side. So I'm going to subtract 3, both sides. So then I'm going to have x minus 3 equals to y plus 2xy. And now I can factor out my y on the right side. Right, so it's x, so it's x minus 3. So you pull out this y here and this y here. So you pull out y, then you are left with 1, right? Because it's like 1 times y. Plus here, you are left with 2x. Right? And so now I have I have just to divide by this 1 plus 2x both sides, 1 plus 2x both sides. And so you see your y would be just equal to, find an answer, x minus 3, 1 plus 2x. So that's the inverse of the function, right? So the f inverse is just x minus 3 over 1 plus 2x. Right. So anyway, guys, this is just to remind you how to find the inverse of a function. This is going to be also on the final. So what else? First test. So the inverse function. Yeah, as I said, transformations, guys. I mean, the vertical, horizontal shift, etc. You have to review that. What else? Let's see. Yeah, that's basically with of course the domain of functions. Anyway, so what I'm gonna do now, guys, I mean, if there's no specific request, I'm gonna do a problem about trig, right? The trig functions. It's in the homework, the problem number 2 in the homework 8, and it's gonna be also in the final. So let me do a problem with the trig. I think so. Last time I had there's an example with sign of some negative angle. So this is so now problem. So about the trig, trig functions. So this is in the final. So it's going to be in the final. This problem is going to be similar to the problem number 2 in the homework 8. Okay, similar to problem 2 in homework 8. In homework 8. So let's say you want to find sine of some negative angle. It could be negative or positive anyway, but let's say you have sine of negative of, let's say 35 pi over, Abdullah, sorry, I say the chat. Can you pause first test one more time? I lost. Yeah, I can post the test on Blackboard, I guess. I can do that, sure. Abdullah, yeah, no problem. Or I can send it to you by email. Sure, no problem. I will do that. Okay. But let me just finish with this trick, because this is important, kind of important. I mean, it's important because it's going to be in the final. So yeah, sure, no problem. Yeah, so I was saying 35 pi, let's say, over 6. Okay. So so for this negative angle, so first step, guys, is that whenever you have a negative angle, and you want to find your sine or cosine, so in the first step, you use the fact that step 1, use the fact that your sine is odd function, right? Is odd, right? So sine of, so what I mean by odd is that sine of minus theta is minus sine of theta. In case of cosine, so if you have cosine, then use the fact that cosine is even. In case of cosine, so we use that the fact that cosine is even. So which means that cosine of negative angle, negative theta, is equal to cosine of positive theta. All right. So the idea, guys, if you start with a negative angle, you can always, using the fact that sine is odd or cosine is even, you can change it to a positive angle, right? So in this first step, so what I'm saying is this sine of negative 35 pi over 6, it's actually minus, because sine is odd, it's minus sine of 35 pi over 6. Okay, so you see it's plus now. So now I have to find this, it's minus, and so sine of this positive angle, right? So now I got a positive angle. Okay. Now, next step. So how do we find sine of some positive angle? Well, next step would be to divide. You have to find how many full rotations you have in this angle. So you have to divide. So divide by 2 pi, which is 360, right? 360 degrees, to find how many full rotations, right? To find how many full rotations in theta, in your angle theta, right? So like here, it's 35 pi over 6. So I'm gonna just divide 35 pi over 6 by 360, the full rotation. So I'm gonna divide by 2 pi. So 2 pi, you make it look like a fraction, so it's 2 pi over 1. So it's just 35 pi over 6 times, and you flip the pi 2 pi over 1, so it's 1 over 2 pi. Cancel out the pi's. So it's just 35 over 12. Now, when you divide 35 by 12, you're gonna have 2, and you will be left with 11. Okay, so 2, and you're left with 11. So it means that you have 2 full. So this number 2 here, this is important. So we have 2 full rotations. Okay, so now in the next step, I'm gonna subtract that number of full rotations from my angle. Okay, because it doesn't change the value of my sine. So, and this next step, step 3, subtract that number of full rotations from theta. From theta. So I have my angle now is just a positive 35 pi over 6. And I have 2 full rotations in this angle. So I'm going to subtract 2 times, so 2 times full rotation. So full rotation is 360 or 2 pi. So it's just 35 pi over 6 minus 4 pi. Right? So common denominator over 6 times 6, top and the bottom by 6. So it's 35. So it's 35, sorry. So it's 35 pi over 6 minus 24 pi over 6. And that will be 11 pi, right? 35 minus 24, it's 11. So it's 11 pi over 6. All right, so I got my 11 pi over 6. So now I can compute my, so last step. Now I can compute, so step 4, I can find my value of my sine. Right, so we started with sine of negative 35 pi over 6, right? Now we said sine of negative 35 pi over 6 because sine is odd, that's minus sine of plus 35 pi over 6, right? Now, in the step 3, I subtracted 2 full rotations from my 35 pi over 6, and I got 11 pi over 6, right? I got this 11 pi over 6. So now this is minus, so sine of 11 pi over 6, right? I just, of course, you have to keep, here's this minus here, you keep the minus. But now, because in the third step, I got 11 pi over 6, right? So it's 11 pi over 6. Now, in which quadrant is this 11 pi over 6? I mean, 11 pi over 6, I mean, pi is 180 degrees, right? So it's, so this is minus sine of, just to convert to degrees, pi is 180, right? 180 degrees over 6. So this is actually, I mean, 11 times 180 over 6. I mean, 180 over 6 is 30. 30 times 11, it's 330. So this is actually negative sine of 330 degrees. So where's 330 degrees? Well, remind you. So this is 0, 90 degrees. This is 180 degrees. This is 270 degrees. And then after full rotation, you're going to have 360 degrees. So 330 is in the 4th quadrant, right? This is, here's your 330 degrees. So this is in the 4th quadrant. 4th quadrant. So remember, guys, so we are in the 4th quadrant. So we have to use reference angle for the 4th quadrant. So the reference angle in the 4th quadrant would be, so this is equal. So here I'm gonna use a reference angle. So reference angle in the 4th quadrant, it just is equal. So the formula for reference angle in the 4th quadrant, it's 2 pi, or it's 360, or 2 pi minus your angle theta, minus theta, right? So like here, it's 330. So the reference angle would be 360 minus 330. My angle is 330, right? So it's equal to 30 degrees. So we have this is a minus. So here's my minus. And so using the reference angle, sine of 330 is actually sine of 30 degrees. But we have to be careful here because we are in the 4th quadrant. So if you are in the 4th quadrant, then sine is negative, right? So there is a minus, another minus here, This is because sine is negative in the fourth quadrant. So sine is negative in the fourth quadrant, right? So it's actually minus minus, that will be a plus. So this is actually equal to plus. So this is equal to plus sine of 30. Now, what's sine of 30? Well, we use a table, the special angles between 0 and 90. So this is the table, special angles between 0 and 90 degrees. And so sine of 30 is just a half, 0 and 90 degrees. So sine of 30, so it's half, so it's plus half. And that'll be fine answer. So you see, guys, so that's how we find the sine of this negative angle. Now, if you have the positive angle, it's just the same steps. The only difference is the first step. So in the first step, we won't have a first step if your angle is positive. All right. So if your angle here, if the angle here is positive, then you don't have to use the fact that sine is odd or cosine is even, right? Because you already have a positive angle. Okay, so we can, if you have a positive angle, you can just move to the step number 2. Okay, so here let me just say, so if you have, let's say, sine of some positive angle or cosine of positive angle, so remark. So if you have sine of some positive angle, let's say sine of 45 pi over 4. Okay, this is positive. Okay, so in this case, you can just move to the step number 2. Okay. Step number 2. Okay, no need for this first step. So no need for step 1. Okay, so you're gonna need the first step if you have a negative angle. Okay, if you don't have a negative angle, you can just start from the step number 2. So step number 2 was, you divide your angle by 2 pi or by 360, right? That's the second step right here. So if you have a positive angle, you can just start from this step number 2. Okay. Any question, guys? So this is also in the homework 8, right? So homework 8, remind you guys, it's due Monday. It's just about finding the sine and cosine of some angles. So actually in the homework 8, there is no negative angle. I don't know, for some reason I forgot probably to include some negative angles there. But anyway, so for homework, you can follow the same steps. You don't need the first step, as I said, because the angles in the homework 8, they are all positive. So you can just start from the step number 2. Does this answer your question, Lenin? I mean, is there any question or? All right, I guess there's no question. All right, guys. I mean, so yeah, so you should expect a similar problem in the final, and plus, as I said, plus some problems from the second test and some problems from the first test. Is there any other question, guys? Any specific question or request or? Okay, so then, as I said, so today I'm gonna just take it easy. I won't go over time. So probably if you don't have any question, guys, I'm gonna probably just stop here. As I said, a final is combination for a second test. first test, and the strict problem. Okay. So then, of course, so I wish you good luck next Wednesday and the test. Again, so the final, sorry, the final is gonna start at 2 p.m. So from 2 p.m. to 4:50, I will post the final as usual on Blackboard. If you have any trouble or any problem, just let me know. All right. Oh yeah, Cheyenne. This is the last day of classes. Yeah, so this is the last lecture. Yes, absolutely. So I wish you good luck, guys, the semester. Yeah, that was fast. Yeah, I know. Anyway, I wish you good luck, guys, in the semester. And I wish you, of course, happy holidays. I wish I can see you probably next year in the campus if you are around. And so just take care and stay safe. Thank you, everyone. And I will post the as usual the recording on YouTube. All right. And if you have any question, anything, just let me know. Email me anytime. All right. Thank you, Mamadou. I appreciate. Thank you.
Professor,
Yes.
I responded back to you whenever you get the chance.
Oh yeah, I got. Yeah. So you can take the test at 9 a.m. I will send you the final. I will send you the final by email.
Okay.
All right.
And then I send it back to you by email?
Yes, please.
Okay. Thank you so much.
You're welcome. Sure. Thank you.
Thank you. Bye.
Bye. Take care, everyone,
Professor,
and good luck. Yes.
Professor.
Yeah.
Professor, I have some trouble. Because, can I text you right now or
Yeah,
email
you can
you?
email me. Yeah, you can send me an email. Sure.
Professor, I already sent an email at. Did you get it?
Which email?
Just
About
in your
what?
Gmail. In
In
your
my
Gmail.
Gmail. Oh yeah,
Yeah.
Abdullah, you send me the Abdullah, right? You send me
Yes.
the I just got the
Professor, I sent you in the final in the second test. I sent you 10 picture, but only 8 went through.
Okay. I'm gonna check. Sure, no problem. I will check it out.
And I already added that other 2 pictures.
It's fine. Don't worry, Abdullah. No problem.
All right, thank you, Professor.
Sure, you're welcome. Oh
Thank you,
yeah. Leo Ver, right? Yeah, you can send me the the final by email to my Gmail. Sure. Yeah. Oh yeah, sure. No problem. Yeah, thank you guys. Thank you everyone. Again, if you have any questions, just email me, right? Take care and good luck and happy holidays.
Happy holidays,
Thank you.
Professor.
Take care.
Have a good one.
Stay safe. Thank you everyone.